Good morning. You've been working with Momentum on Khan Academy for a little while, but I wanted to take a little time to do a little touchy-feely Mr. Green explains Momentum. I'm sure that you can go look at all of the definitions on Google, but for me, I just want to kind of make those connections because we see or hear the word momentum out in the real world. For me, my first real connection to momentum comes from I'm a nerd, right? Magic the Gathering. So playing card game from Urza's Destiny. We've got this illustration of a hippo that is kind of charging after someone. The card's called Momentum. So for a green and two colorless, you can enchant a creature and it starts to get +1/+1/+1. It gets bigger and bigger and bigger. And that's what we feel with momentum. Something is gaining momentum. Its momentum is changing. When you talk about something large like a train that's accelerating, right? Its momentum's increasing. Or we think about momentum when we're trying to stop something, right? That car is just kind of rolling. Boy, it's got a lot of momentum. It's going to be difficult for us to stop. So really, momentum is anything that has mass and is moving will have momentum. But we tend to think of it as something large, like these two meteorites. Now, I'm assuming these two meteorites are the same size, and we can think of it as if these meteorites are both flying through space, then they have momentum, right? They're large, they have a mass, they have a speed, and I can slow them down. I can slow them down with a really, really small force for a really long time. It would take a while. Like imagine like trying to slow down a train while pulling on a rope. You could slow it down eventually to a stop. Or we could put a wall in front of it and provide a really, really large force for a short amount of time. And that's the safety device thing that we were talking about before. We can decrease the force by increasing the time. But it works in both directions. So if this object were not moving, then I could provide a small force. And as I continue to provide that force, it is kind of accumulating that force. And that's the way that I think of momentum. Momentum is kind of the amount of accumulated force. If I give a small force for a long time, this object will have a lot of momentum. Okay. If I provide a really large force for a small amount of time, it would still have a lot of momentum because it's a large amount for shorter. But either way, the longer that I push something, the more momentum something is accumulating. The more I think of it as momentum as the amount of accumulated force. So you guys in Khan Academy were asked to work with force time curves. Okay, and that's exactly what this is doing. When we were asked to find the area here, this was the amount of accumulated force, which was actually the change in momentum. So the object had some amount of momentum. It had accumulated some force. And then we give it more force for more time. So it changes the amount of momentum. It accumulates more force. Okay. Now, you weren't given this equation specifically because this is really two equations. But I just want to briefly talk about this because this will be helpful if you go back to that. The change in momentum, that area under the curve, is this delta P. Okay, so if you find this area here, you can use it here as the value for this variable. Force and time are two things that we talk about in terms of the safety device, but change in momentum is also equal to the mass times the change in speed. So m is the mass, we know that, but delta v is the change in speed. So in that Khan Academy, when you were asked what is the change in momentum, it was asking you to find the area under the curve because it was asking you how much force did we accumulate. When we were asked for the change in speed, we were going to find this area and divide it by the mass, because this wasn't here, to find that change in speed. So summarizing, momentum to me is accumulated force over time.